Hi, today we are going to do day 10. We're going to look at basic list operations and we're going to do loop training and how to iterate through lists specifically. And within loops, how break statements and continue statements are used, right? So if you have a data list, like list in a data, then how do you iterate over it? And then how do you control the iteration process of, how do you stop or break your loop or continue your loop based on conditions in there. Uh, so I'm going to look at that. We can also put if conditions that we covered yesterday quite in detail. We spent 2 days, multiple hours looking at if statements in control flow. They were conditional statements. If you guys remember the code yesterday, specifically we looked at a bunch of input statements, and then beyond those input statements, how uh, we created a dictionary and we loaded this dictionary with values up here with variables, right, to make that dictionary a full data type, you know. And then we went ahead and ran if else operations on those dictionary values, right? So we did dictionary access and then booleans and floats, right? So to give an example of what line 39 is, right? It's a if else control statement that's run on a dictionary variable, the key, and we're running a check and against a float value that it has in this syntactical structure of a if statement, right? We did that. We did list comprehension as well. We created lists of or objects that we ran strip functions on, and we did comma separated splits on. So we did split, and strip of strings that were inputted that were input via the keyboard into objects in our data structure. So we did all that stuff yesterday, and today we're going to again we're going to look at loops, and we're specifically going to look at how to create them, how to access them, how to modify, slice, and delete list elements first. And then we're going to look at dictionaries probably tomorrow on how we can use loops to go through the dictionary data structure, right? So let's focus on lists a little bit today. So we're going to do lists, loops, um, break statements, continue. So break and continue are keywords that we use inside of our loops, right? And we can do nested for loops uh, for while loops. Okay, so that's kind of what we're gonna work on. This is so we're gonna work on this. All right, let's make a right, and this is a 9 and 10 day file. So let me uh, rename this. This is day 8, day 9, right? Right, and then this is our day 10 file. Right, so this is our day 10 file. So basically, let's create a list. Let's call it my underscore list. And let's just put some numbers in here instead of name. I mean, we can. You guys know that we can put anything inside that list, but we're just gonna put some integers. They're whole numbers, so they're integers. They don't have a decimal. If they're decimals, there would be data type float. So we could do a print statement, and we could go. Go my list. So let's run it. It says that our virtual environment is not selected in our code space. Why is it not connected? Let's do a interpreter selection. In our workspace, we can go to a virtual environment in Python. That should select it right there. Right. So that's our run output right there. Right. That's our original list. Let's take this. Put this whole thing into quotes inside a list. Go here. Oh, if you guys remember, what was the hotkey we learned? Control Shift down? No, that wasn't it. Let's try it again. Control Alt, Shift Alt down. Okay, there we go. And then Control X, Control V. There we go. String. So we go. String list. Good. And then there's the shortcut to run code. Is there a shortcut here? There isn't. Okay. If you notice, look at the second output, right? So the first output here, everything is an individual item. It's over here in the list, right? 1, 2, 3, 4, 5, 6, or whatever. In the second one, there's only one. So if you print something like this, right? If you look at the length, you do print length of my list, right? And then do this, and then do this. You'll notice that they have different lengths. The first list has a length of 6, and then the second list has a length of 1. Right, so you're seeing these different lengths because we are wrapping all this data inside, and this is actually just one string, 1 through 6. Right, so this in here you can remove it and be like, is this okay? What? Yeah, is this string type? Yes. Yes, it is. Because you can go here and do type. Right, and then run that, and it'll tell you that it's a list, right? Right, and then if you give it an index over here of 0, it'll say, okay, let's do this. Let's go here. Okay, let's see what the output now is, right? So you have list and string. And you have list and string over here as outputted, because the first one is taking this entire thing and saying that what is this whole thing, including the brackets? Oh, it's a list. And then inside the brackets, if you look at the first part, which is inside the which is inside the index, the first part, which is this entire thing inside the two quotations, it is a string. This type is a, you'll notice, is a integer. Let's say int over here. Right. Right? You see that, right? Why is it not printing int? Oh, it's not an int. We're gonna do, it's a type, and it's gonna print out that it's an integer. It's a class int. So go to the bottom. There you go. Right. Okay. So we saw indexing. Let's do slicing, right? So this has 6 pieces in it, right? So we could do something like this, like print, and then go my list, and then indexes. It starts at 0, right? So we go 0 from the beginning to the end. So this will print out everything from the beginning to the end, I think. I don't know if I remember. I hope I remember it. So this will print all 6. See it right there? So it'll go here, it'll go here, it'll go. Beginning to end. Beginning to the end. That's this code right here, right? Now here, if you go like this, what does it do? It again does everything, beginning to the end, right? And then let's go over here, and let's go, I think this will print nothing. If I remember correctly, it's an empty, okay, print nothing. All right, so it prints nothing, and then this 5. This length is 6. So from 0, 1, 2, 3, 4, 5, 6. Right. So to 5. This is gonna print everything. There you go. Right. So this is Sprint. This is list indexing. And I mean, just because it has 6, right? If you had a string of 6 different strings of a list of any kinds of strings, this indexing would still work because we're using an index to access it anyways, because an index is an accessor of a list. An index is an accessor of a list data type. Okay. Okay. All right. Now that we have that sorted out, is there any other kind of... Right. So what happens is, what if we do this? New list is equal to my list plus the string. What was the string? My list string, right? And let's see if it prints the integers. It should print out it should print out this thing with 6 numbers and the list at the end. So what do you guys think the length is going to do this thing? Set. And what type of data is this whole thing? It's a list, right? Let's look at something else. Let's go to my list. And let's look at the first index, right? Or let's look at the third index. What is the third index? Third index, 0, 1, 2, 3 is 4, right? So we're going to test that right now. We're going to go here, we're going to go here, we're going to go print, delete my list. It should print at 4 on the console. Right? You see 4 right here. So you say, hey, is this equal to 4? An integer. You're going to typecast this as an int. The answer should be true. It's equal to int 4. It should say, if you're checking this, how do you check it? Oh, but this does. This is the check, right? So you can write an if statement here. So you could say if my list or print guess the check is true, right? It is, yes, check is true. So it is printing at 4 up here. But I wanted to check something else. I want to see if we can change it. I guess a single thing will change the integer to 9. Let's change it to 9 and see if this runs. And then go run. What is the new value of this, right? So of my list index number 3, what's the new value? It should be set to 9 now. It just says 9. The length of the new list is 7. Okay, so it changes it, whatever. Like, so whatever you put, let's say you put 7, or let's say you put, oh, no, what just happened? Okay, so we go here, we set this new value, right? That's what's going to happen. So the new, now if you print the entire list, print my list, Control Z, and then print. This is quite interesting because you'll notice that it won't update. Oh, why is this not working, man? Shift, not Control. Okay, and then it's my list string. Okay, so this one is the new updated one. So what we're doing is we're only changing the value on the string up top. We're not, but then later we're adding the 2, but we're doing it later, right? So you're not seeing that printed out in here. You're seeing, is this a string type, the original being printed over here? We created this addition into a new list. If you come down over here and you go, that too should not have the updated value of 6, 4, 5, 6, whatever. It only gets appended to this new thing. If you want to add it over here to whatever, we can just directly do a plus sign and add that. Right, so if you want to go here and we want to go something like this, and we do this, and we go alphanumeric, right? And we save and run. At the very end, you'll see that. Why didn't it add it? Oh, maybe we do. It has to be in the list. So you can add lists together, but it can't just be a string. You can append it. So there's a specific method that lists have inbuilt in them. So if you go to the debug console over here, and you go to new list, what is going on, man? Shift underscore. There we go. Okay, that's what it has, right? So if you go here and you put dot and do append, APPE, like that, and do that, and you give quotes. Then if you give something like this, it'll work, right? printed, you'll see it at the end. Okay, so that's how you can use it. It has a lot of so we'll go at it, right? There's a lot of inbuilt methods that you can do for list operation, but we're just covering some of these, right? Um, I think we've done enough lists. We've played around with lists quite a bit. We should do some loops now, right? Let's do a couple of other little functions really quick. So we go to my list, right? Let's do this really quick. So that sets up, right? Right, so you added the number 9 to it, from what it was, right? What else you can do? Let's blow that away. Let's do length of my list. So what's the current length of my list? New list is 7. The original list had 7. It was 7. So from here to the end, right, we can add a value of 155, right? And then we can try and print it. So why isn't the slicing working? This is a slice. We could do any length in here, I think. We go the string. This is the length call, which is basically passing an index to it. Let's print out the len. Oh, okay. So it goes from 1 to the end. Prints all of those, and it changes all of those to 155. This should work. Let's see. Mm. Okay. So wireless length. It's 1, 2, 3, 4, 5, 6, which is length is 7. What do you see in the console? My list len 6. 6 to the end. So what does my list? Oh, there's nothing there. That makes sense. Oh my god, I'm so stupid. What this really means is 6 to the end, like that, which is nothing. So if there's nothing, how can you assign nothing to this, right? Uh, so what you can do to make this work is put in 5 like that. So this 5 to the end is 6, which is this. We want to change the value of that. This should work. Copy. Why is it? Five to 6. What is this? The value of 6. So if you take the value of 6 and you want to switch it to a number, we should be able to assign it. Take this value and assign it to a 9, to a 5. Weird. Okay, so we found something very interesting in Python that it doesn't really make sense, but let's look at it anyway. So if you go into an index here, if you print out just index number this, right, and you can set a value here to that for this, it did no problem. But it doesn't take index range in here and then set the value to that. So if you go 5 through 6, it'll error out. It'll give you an error, right? But if you type in my list, right, and you print it out, it changed this value 654 in the last place with this code, with the specific code. So this, if you want to change it, is just 5. So you can just go to the position and mute it, but you can't mute it with an index, which is wild, right? And then if you want to like delete, you can use the delete command, and you can actually give an entire list in there. You give it this, right, and then I'll just get rid of the thing. So if you run it, if you print it, it should give you an error. Yeah. Basically, after you run delete on it, it's saying, hey, there is no, on line 33, is saying there is no object, so why are you making me print this object? And if you comment it, it'll just delete it, and that'll be the end of it. All right. So these are the operations. So we did list operations on lists, and we just refamiliarized ourselves with that. Let's get into looping over lists, which is our second part, right? So this is part 1. Right? let's get into part 2. Okay, so let's get stuff from yesterday. We're going to do loops, right? So let's do, where did I put them? I'm trying to think. Let's copy these. That didn't work. And then it work. So we created a list, right? Then we can create another list saying, looks like that. Just copy over some of these courses. Let's take this. All right, so the length of this course is taken in AI courses. We can run the length function on that and figure out how long they are, right? So we could do something like this, right? So looping, right? So we could say for subject in courses taken print courses taken right. So it's gonna print AI of these parts right here, right? So if you go here and you comment everything else out, right? You just come over here, you just have these two parts right here, these two items, these two variables. We run through our stuff and it says, hey, look, it's printed it out, right? Now, if you put a count is equal to 0 here, right? And you know that each item, it's printing the whole list out, right? print out? Oh, it should say subject. Sorry. I don't have to use an index because I haven't gotten to that point yet. So let's look at this again. The output prints out exactly what courses you've taken from the list, right? So that allows you to print out all the courses. What we can also do is we can write another for loop with an if statement, right? So for subject and important courses, print subject, right? So it's printing the other ones right here. So these are for subject. So for subject and course, important course is this. Right now, we can say, hey, if subject, right? Or let's do this. Let's switch this term right here to courses because we're using it in 2 locations. We change it to courses here. Control exit, important course. Course taken for subject. Subjects taken. This will give a little bit more clarity. So the separation happens over here. Let's run again. All right. So you're saying subjects, AI fundamentals, algorithm statistics, and then you're saying important subjects, which are 5 of them. So there are 2 math courses, an algebra course, and the AI ML fundamentals, right? That are important. And the subjects that you've taken so far, you've taken 3 out of the 5, right? So now in the second loop, right? If you copy this guy again, and what we're going to do is go here. We're going to go tab. We're going to enter, and we're going to put an if statement in there, right? So we're going to say if course not in courses taken. So what are the courses that are not in courses taken? Discrete math is in there, right? And ML is in there. So these 2 aren't there, machine learning, right? So we're going to say this, hey, if courses not in courses taken print that these are pending courses or they're missing, right? put it that it's missing it there. Right. For course important courses, if course not this is missing or it's found, right? So we can go here because we don't want that, right? So now let's run it. Saying discrete math is found and machine learning is missing. It's saying these two that we talked about that were missing earlier are indeed missing. So our logic is pretty good. Now, we can move it down here. Yeah. The way these loops were, they were nested, and we don't want them to be nested. I was just typing them up, and they ended up nested, right? It's not in courses taken. So here, let's try and add something to this thing now. Let's take this again. Let's put a let's go in here. Let's put a break statement in here and a continue, right? So of course not, if there's a missing course, we can break it here, right? We could put the keyword break, just like that, right? So missing course. String. So it's missing blah 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 course. So breaking the loop, right? We can do this and then give a new line right there. And then if we found statistics, right? So we're gonna find statistics. So we're gonna say if course equals to x and course skipping extra checks, For this, we can put in continue, right? If we do something like this, we could put print processed. All right. All right. Do you see what it did? Let's this. Let's run this guy. All right. So it's process AI fundamentals, right? And it's missing machine learning. So then it broke right there. It found statistics, but didn't find machine learning, right? So it did that, but then it broke the loop instead of continuing on because we had a break statement in there. So that's you can break check your checking, right? So if you continue checking, if you remove this break statement, it'll run twice over, right? And it'll print everything. It'll print both out, right? See how the output size doubled because it didn't break. It just found the two missing courses twice. It found discrete math down here. It found machine learning down here, right? But by stopping it, you only print one out, like that, right? And by continuing it, it's going to go through. It's going to go through the logic. It's not going to have a stop there. It hammers it down. The continue kind of like guides the river where you want it to go. Kind of like you can. It's like a dam. Like you can kind of like you can guide the flow to where you need it to go, right? That's the use of a continue statement, and a break statement is more of like an abrupt stop in the middle of your program, right? So that's how you can kind of think of these. Let's do some looping over strings, right? So let's go and have a student name here. And we can put Tommy Walters. Okay, that's your student name. And right, you can see something like this, right? For character or char in student name print right, something like that. I'm gonna Google something really quick. How do you use print to string Python examples? I want to print hello world, print function, print hello separator this. You can use a modulus, which is pretty cool. SND. Oh, it's dot format. Okay, cool. So think of it this way, right? So let's see if I can Google or alphabet in string this, what is it, dot format, and then in brackets we put character. So this should print out everything in an alphabet. There you go. Tommy Stewart. Do you see that? So that's how it used the format statement. Pretty cool. Let's see if we can use another one. Mod S and mod D. What do the modulus operators do? So in here, alphabet and string, mod S, like that. Huh. Another mod. And then just a bracket like that. I wonder if that'll take it. Let's see if it prints it out. Did. Do you see that? Okay. So you can put mod S. What does modulus S in a print statement in Python mean? What does modulus S in print Python? Okay. Okay, module test is for string replacement. D is to replace integer, and .1f modulus is for a floating point number. So that's important to know here with these. Put this in here. You can use the same format if you are using, so we're doing strings, so it worked. But if we're doing integers, for example, we would have to use modulus D. And for float, we would have to use modulus, what is it? .1f. That makes sense, right? That we would have to use mod D. So if it was a string of numbers, like here, like my list, if we comment this and then we go through an iteration through my list, right? So then did I use my list again? No, I didn't. I used courses and students. Okay, so let's go to end home. For integer end for number in my list, print. So this is how we do it. Number in my list is this, and then it would be mod D, wherever it is, if I can find it, mod D, and then another mod, and then whatever the variables that we're using number, right? And it would print out all the numbers, 1, 2, 3, 4, 5, 6, or whatever. Okay, so that's how you use these specific strings inside for loops. Cool. Right. We could do a nested loop. Let's do a nested while loop. We could do one of these, right? So letter 1 equal to A. Letter 2 is equal to, I a string to question mark. Two variables, right? Give it a .com, give it a .com dot format. What we have here, letter 1, letter 2, character word. Letter 2 plus 1. Print all right. Just went through the entire alphabet, right? And you generated all of them because you used two inbuilt um, they're hash maps, really. So you used a while loop. So it says while letter A is less than equal to Z. So it's going to go through the entire alphabet over here. And then it sets letter 2 is equal to A, right? And then it kind of deals with this. I'm going to check something over here for this. It's GHR. All right. Yep. Yep. Okay. So this is an ASCII. These are both ASCII conversions. I knew it. So Python, what it's doing is when it's using these data types, under the hood, it's using hash maps, and I had a sneaky suspicion that that's what it's doing, and I kind of knew that. So hash maps are data structures that come from C++, and in C++, there's memory management. What Python does, it has an internal garbage collector, and what it does is it's assigning kind of a data structure with an index. So it's internally building an index, and it's building that index based on an ASCII value. That's what this is, right? So um, let me put this in here so that you guys have this. There we go. Same thing. Over here. If you're wondering how I got this, right, is I was setting for loops of hash maps in algorithms, and that's where this comes from. Um, you know, that's just literally what this is. This is an ASCII value. So if anyone ever asks you how to reverse a string or something, and they want to know what the algorithm is, um, think of it, right? So let's say we have this long list over here like that, and you want to reverse this list. The unique value T O M M Y automatically M is repeated twice in the string. So if you try and alphabetically reverse them, whatever for loop logic you use, there's going to be a clash that's going to happen, right? So if you don't want to deal with the clash and you want to somehow get rid of the clash, or you have to use the ASCII values, because the ASCII values, that and the index, both of those are internal, right? So even if the ASCII value is the same, it's on different indexes. The first M is on 0, 1, 2, is on 2, and the third M is on 4, is on 3, right? Index number. So with it having an internal index and having those, it'll reverse everything and then reverse those two as well, even though they're the same ASCII value, because of the nature of that character and OD piece. So that's what this is. So that's what we'll probably get into more um, nested, crazier loops um, after after tomorrow, and we actually go into the algorithms. We're gonna get into dictionary parsing next, and then we're gonna do key values and items. And when we do the key values, you'll be able to look under the hood of Python a little bit more and look at hash maps and how they behave. So we'll look at that. Okay, so that's it for today. That's for loops and while loops and nested loops, and for loops with if statements. And we all did that basically on lists, right? Uh, right. So look over this code. If you have any questions, let me know. Send me a message. If not, we can work on um, looking at hash maps a little bit more tomorrow, and we can look at the functions and how loops work inside those functions tomorrow, right? So we can kind of work on that. All right. Thanks so much. Take it easy. Don't stop coding. We will continue tomorrow. Have a pleasant evening. Thank you. Bye.